Hello and welcome to FEM Expert. Today we will present you a medium tutorial in which we will show you how to create a cantilever beam and perform a static analysis on it utilizing the Ansys APDL language. We will start with a fresh Ansys instance, and well, what we mean by APDL language is the programming language that Ansys utilizes behind any of the commands or any of the actions that we do. For example, when we try to do anything, let's see, we can list lines. We hit OK, we have no lines. Then if you go to list files, log file, we will see that in the log file, besides a bunch of default commands, there's list, which comes from line list, comma all, which means listing all the lines. So behind any of the actions of Ansys, there is a command line that creates that action. So actually, to be more productive, you can use these command lines to model or create or simulate anything. So today, what we will do is perform the same cantilever beam analysis of a simple beam from the way of the command line or the programming APDL language. Okay, so what we'll do right now is create two key points. In order to create a key point, you can utilize the key point command, which is k, comma, the number of key point. It will just ignore the number of key point by putting a comma. It will put the number by default. It will automatically select the number. And we'll put the coordinates of this key point equal to 0, 0, 0. We hit enter, and we'll see that a key point has been created. Points type num. Then the second key point is going to be k, comma, comma, 1 meter on the x-axis, y, z, 0, so we ignore them and hit OK. So as you can see, there's one key point, the second key point. Now we have to create a line. For the line command is L. Most of the commands are related to the word that you would normally use in English for that action. So L comes from line, and here you have in the autocomplete, you can look at the information on help to see what all these things mean on the autocomplete, but also they're very intuitive. For example, line is composed of point 1 and point 2. You hit OK, and we have created this line. Okay, so once we have the line created, the normal procedure will be defining the element types, material properties, sections, modeling, meshing, etc. So for the element type, we're going to do the ET element type, comma, the number of element type 1, and the name of the element type is 188. You also have the key options that we're not going to touch. We're going to use the defaults. We hit OK, and you can go and actually look at the delete if the element type B188 has been properly defined. Okay, the next step on the line would be real constants. The element type 188 doesn't need real constants, but we need material properties. For the material properties, we're going to use MP, which is material properties. The material property, here you have to look on the help or be aware of what material property you're using. These properties have some shortcuts, so we're going to define density on material number 1, and the value is going to be 7,800 kilograms per cubic meter. We're going to do the same, MP, comma, material number, the variable is EX, which is Young's modulus, comma, material 1, comma, 2.1 E11 pascals. Okay, and the third one is MP, comma, PRXY is Poisson's coefficient on material 1, and the value is 0.3. After we have done that, we're going to go and check material models. Material 1 is defined. We have density 7,800. We have linear isotropic 2.1 E11 EX and PRXY 03. So everything is fine. Okay, so for the next step, we're going to define the section. The section can be defined with the command line sec type comma, the section ID is number 1, the type is beam, the subtype is hrec. As I said, you have to look on the help. We're going to show you the result after this, but anytime you have you want to see a command or anything like that, you have to go to the help and be sure of what are the variables that you're introducing. So beam hrec, the name would be the name that we selected, beam. So we hit OK, and now we have defined the type, the section type. Now we have to introduce the sec data. The sec data is 40 divided by 1000, with 60 divided by 1000, because we're working in millimeters. We're working in meters, and these units are in millimeters. These are the width, height, and now the thickness of the profile. We have 4 thicknesses for each one of the wall sides, so you gotta be careful introducing them all right. We hit OK. Now we're gonna go to sections, beam, common sections, and want to check the ID number 1 is a beam with a subtype of rectangular hollow profile, and the dimensions are 40, 60, or 40 millimeters, 60, and 3 millimeter thickness on all of the directions. So we're fine, we're good. Now, okay, so normally the next step will be going to meshing, and going to mesh attributes, pick the line, select and introduce the attributes. You can also do that with a command line, and that command line is lines attributes, L-A-L-A-T-T, lines attributes. The material is going to be 1. There is no real constant. So we have no real constant, type 1. We have to leave an empty space. The KB and KE, we ignore them, so we have 1, 2, 3, 4, and the section number ID is 1. Hit OK, and we can do a line list, P, and see the properties that we have assigned into this line. So we have material number 1, material 1, type 1, and for the section we will have to list it in a different way. So we're good. Right now we're doing fine with this line. So we told the program that this line has these properties. What we have to do now is selecting a meshing size. For that we're going to use the E size, which is the element global size, 0.25 in this case. Or we can choose the number of divisions, but we're just going to use 0.25. Now we're going to use the line mesh command, pick. We select this line, enter. We have elements, so the line has been meshed. And now we have to go into the solution module and apply the restrictions and the force. The restriction is going to be at dk, p. You can use d, p for nodes, or you can use d, p, dk, p for displacement on key points or displacement on nodes. We're going to use dk, p is the same thing. Depends what entity you have. So we're going to hit OK, select this node, OK. We're going to select all degrees of freedom 0. Okay. As you can see, there is a restriction on the node 0, and at the other end we're going to apply a force, and it's going to be done by Fk, force on a key point, key point. We can hit OK, select the key point, click OK. It's going to be on the Y direction with a value of minus 100 newtons. So we have it all. Now the next step is to go to the solution. The /solu or takes you to the solution menu, and then we go to solve. We solve the model, and what we have to do is go to general post-processing. For doing that, we have to go to the /post1, which will take us to post1, and to read results we can do the set last command, which means read results last set. And now to visualize the results, we should go to plot results and contour plot, vector plot, whatever information we want to get. So for contour plot, we can do PNL sol that summation. That's the summation, the resulting summation displacements. And as you could see, we have the beam has been deformed. We can change the views. It's been deformed by the weight of the force, by the action of the force, not the weight, sorry. Okay, now we're going to look at PNL solve stress equivalent stress of omisses. The stress here is not being shown because we will have to utilize the 3D element shape option. We're going to talk about it in other tutorials. We're going to look at the PLVect U is the vector plot, because here we have contour plots, vector plots, and what we just did is a vector plot predefined for translations. As you can see the displacement vectors and so on. You can choose to see any other options. You can see PNL sol UY. This is the displacement on the Y direction, and so on. So for right now, we're gonna finish this tutorial. The scope of this tutorial was to get you used to utilizing the APDL programming language and utilizing the Ansys commands to do various simulations. I'm gonna go and quit no save, and so now you know how to utilize the APDL programming language at the basic level. We would like to thank you for your attention, and we hope you enjoyed this presentation. For more tutorials, please visit our community and follow us on the social media. Also, if you enjoy the material that we have been creating, please consider making a donation, and because all this stuff requires a lot of work.